What can we expect from the test objects which are printed far above 400 degrees Celsius? And I have 6 types here. Hello, welcome back to another industrial material testing video. After my PEKK versus PPS-CF video, I was contacted by several companies who wants to print these test objects properly for me from these materials, and so I can test them. One of them is one of my viewers from Czech Republic. He have the access to the Prusa HT90 printer, and he can print with these 6 exotic filaments. And this is not a sponsored video. I got these test objects for free, but I'm not paid to do this video, and actually the viewer don't even want me to mention his company. I got so many information that I collected everything in one PowerPoint presentation, and after this I will show you some footage of the printing and about the materials. All test objects are printed by Pavel from Czech Republic, and all materials from this video are by 3DXTECH, and they are printed on Prusa Pro HT90, which is equipped with 0.6 mm nozzle as a default. And here you can see these 6 materials from this video and their prices. If you want to know more about these materials, you can pause the video because I will not read now this text. And these are valid for all these materials. So they're not printable on home printers because of these higher temperatures, and printing have to be very slow without cooling, or almost without cooling, except PPS, and they're extremely prone to warping in X and Y direction, no warping along the Z axis. HT90 printer is able to print them, but not big objects because of higher recommended chamber temperatures, but here we have the limitation of the printer. And bed adhesion is not really good, and using of the glue stick or Magigo HT, which is officially recommended, is mandatory. And drying is extremely important. Here you can see the maximal speed and flow rate, and the annealing after the printing is important to reach the full mechanical properties. Here you can see the drying information, so mostly approximately 4 hours on different temperatures. And these are the recommended print temperatures by 3DXTECH. And these are the default temperatures in the Prusa slicer, the recommended bed temperatures, and they use chamber temperatures, and in some cases it is recommended to use even higher temperatures, but we have the limitation of the printer. And these are the glass transition temperatures, where the material becomes soft, and basically the annealing has to be done above this temperature. And HDT, heat deflection temperature, where the material can hold some weight without deformation. And these are the annealing informations, the time and the temperatures, and it is important to have this material somehow supported during this annealing. The ideal is the forming sand, but here the baking soda is used because it has very small grains, and it is cheap and it can be used several times. And these are just some comments by Pavel. The easiest for the printing was the PEKK-CF, probably because of these carbon fibers, and I have this experience with the regular materials too. Two hardest for the printing were the PPSU and the PPS materials. And now these footages are recorded by my viewer. This is the drying process. And now the filaments. This is PSU. PPSU. PPS. PEI 1010. PEI 9085, and this is PEKK-CF, very brittle material. Oops, there goes the end of the filament. And some footage of the printing. This is the leveling process. Printing with PEI 1010, huge brim he used here with the bigger objects. This is end of that printing, and it is quite slow. And this is PEI 9085, huge brim here too, and PEKK-CF, printing directly from the filament dryer on quite high temperature. And according to Pavel, this is easiest for the printing, and I also got this twist drill. I will test it later. So these are those parts, and beside my regular test objects I have these hooks, and I can see from two materials I even got this twist drill, so it will be a very interesting testing. And I will be able to add this information to the summary table for my Patreon supporters, because these objects are typical which I'm using in this kind of videos. Some objects still have this brim and I am cleaning them now, and even now I can feel that this will be much stronger material. It's really hard to remove it. I think this brim and support should be removed before the annealing. One more time a closer look. So this is PSU, very nice print, partly transparent. This is PPSU, and it was extremely hard to remove the brim and the supports. This is PPS, and I think this is the ugliest for all six. This is PEI 1010, and here I got this twist drill too. This is PEI 9085, nice printing, and I think the nicest is this PEKK-CF, and from this I also got this twist drill too. I will just check one dimension. These are for the ISO impact test and they are printed in this position, so I will measure it above the elephant foot, and some of them are quite ugly. For example, this PPS. You can see how inaccurate is this shape at the end. It's partly curved, not flat. The design length is 80 millimeters, 7944, wow, 7848, 7904, 7879, 79.19. This should be the most accurate, but it's not, 77.23. So maybe these are strong materials, but as you can see we cannot really count on the dimensional accuracy. Maybe this shrinking is the result of the annealing process, but even then, this is the result, so we have smaller test objects now. Tensile test, and the maximum of this hanging scale is 200 kilograms. I hope it will be enough. These test objects are printed in horizontal position. This is the average number, but on the left side you can compare this number to other materials. And now the layer adhesion test with vertically printed test objects. The hook test, where we have some combination of the bending and the tensile stress, well, mostly the bending, but both are presented. Two-sided Shear test, and these test objects are printed in horizontal position, and the maximum of this hanging scale is 200 kilograms. And the first material, which was too strong for this scale, and this is how it looks like after this attempt. I switched to the crane scale, and this time it was broken. This was over the max too, but still measurable. And I was ready for the PEKK-CF, slightly above 200 kilograms. And again the Shear test, but this time these objects are printed in vertical position, so the layer adhesion is very important here. The torque or twist test, and I'm starting with the horizontally printed test objects, and I'm measuring the load at 90-degree rotation and the maximal load. 1.9, 1.5, 1.7. For easier following, I separated them in two groups. 2.4. Interesting situation we have here, especially with the last three. This breaks very suddenly. This has a weak layer adhesion, it delaminated between the layers, and the carbon fiber version of the PEKK breaks too early. And now vertically printed test objects where the layer adhesion is important. 0.7, 1.3, 1.5, 0.9, 2. 2.2. Interesting to see so many different break types. Some of them breaks very suddenly, some of them along one layer, but somewhere that's not the case, probably where we have a better layer adhesion. Impact test, the zero position, PSU, PPSU, PPS, PEI 1010, PEI 9085, and PEKK-CF. More or less these are brittle materials, of course not like PLA or PETG, but the toughest from these is the PPS, but again I can see some correlation between weaker layer adhesion and resistance to impacts. And now let's analyze the footage, and I sorted them from the most brittle to the toughest material. PPSU, PPS, and here you can see our results side by side. 3-point bending test where I will place these loads one by one, and I'm measuring the deformation after 1, 30 and 60 seconds. And again I will separate these test objects in two groups. And this is the second group. I can see some permanent deformation on these test objects, but some of them had some warping before the testing too. But the bending test always starts with the zeroing. And at the creep test, the deformation under the constant load of 1.25 kilograms. And I will measure the distance between two reference surfaces in the next 5 days. Without load it should be 12 millimeters. 16.17, 17.53, 1694, 1525, 1637, 12.50. Quite big start deformation on all 6 test objects, but this is the creep test where the additional deformation in next 5 days is important. I already measured them, very minimal additional deformation during these 5 days, but far the best was the PEKK-CF. And the permanent deformation is very similar, but as I mentioned, best is the PEKK-CF. These are directly measured values, but difference between 2 days is this creeping, and that we can see on this graph. And even if you think that there is some creeping on day 1 with some objects, but basically this is very minimal, pay attention to the scale. All 6 perform quite good here. The temperature test in the oven, and there is a quite big difference in heat deflection temperature between these materials, and maybe some of them I have to take out earlier. Even this time-lapse video is speeded up because nothing changed at the beginning, and only 2 test objects deform in this test, and then I stopped the experiment to see how hard they are after reaching this temperature. 215 degrees Celsius, I will stop the experiment here. I will stay quiet so you can hear the knocking on the test pieces. It's time to have some real fun, and I will test these twist drills. I will drill this plasterboard, the thickness is 1/2 inches, and this hole is created in that video where I used the ASA twist drill. The hole was created correctly, but the twist drill was damaged, and I will see if these 2 materials will survive. Just quick check of their current state, and I can even feel that they are quite sharp as they are now. PEKK-CF. The holes are really nice. And I already analyzed them and they are still in perfect shape, so if you need a teeth drill instead of ASA, use these materials or steel. And our results one more time without any comments, and these 6 lines will be added to the summary table for my Patreon supporters, so they can easily compare this data to any of those which I did in earlier videos. And from these 6 materials, far my favorite is the PEI 1010. The only disadvantage is that it's a little bit brittle material compared to the other materials. This was really huge work, not only the testing, but for this video editing I needed more than a weekend. But I'm not really complaining here, because yes, I earn only $10 per video, but my main motivations are my Patreon supporters, and I know that they like exactly this kind of videos, and that's independent from the number of views. Only I'm a little bit sad if this video is stuck on, I don't know, 5 or 6,000 views like my average videos. But let's not forget that Pavel, who printed these test objects, he did a huge work too, and he didn't even want me to mention his company, so I know, big thanks to Pavel, and maybe you can write him some spiritual thanks down in the comment section. Now about these materials. Don't forget that I'm testing only mechanical properties, but there are other things too, for example chemical resistance, or from that PEKK versus PPSU video from comments, I know that the PEKK is widely used in medical applications because it doesn't irritate the skin versus PPS-CF. So if you have some additional experience with these materials, write me down in the comment section a few lines. Thank you for watching and happy printing!